Hello friends, welcome to AutoCircle. We'll start with lecture 2 for CAN protocol basics. In this lecture, we will cover CAN physical layer. Let us start with having a look at OSI model and we will see how CAN fits into OSI model. So the OSI or Open Systems Interconnect model describes a communication as 7 layers starting from physical, data link, network, transport, session, presentation and application layer. The first layer for CAN is physical layer. Here the protocol unit is bits. The second layer for CAN is data link layer. Here we will talk about frame. And the next layer for CAN will be application layer. Here we have multiple protocols defined for the data like CAN open. Now let us see the typical properties of CAN physical layer. So CAN being a digital communication has only two possible states which are 0 and 1. Now here 0 is called as dominant bit and 1 is called as recessive bit. CAN is a two-wire system. These wires are called CAN high and CAN low. These two wires are twisted together and then shielded. This is done for EMI reduction. Now let us have a look at how CAN high and CAN low are physically present in a recessive and dominant scenario. Now as you see in recessive state, the voltages of both CAN high and CAN low is nearly same and the differential voltage will be roughly 0. In dominant bit, CAN high voltage is significantly higher and CAN low voltage is lower, which amounts to roughly a voltage difference of 2 volts that will be seen in the dominant bit. All of the voltages are with respect to the low voltage ground which will be present in the vehicle, which is generally vehicle chassis. Now let's have a look at how the CAN bus looks in a vehicle. So here we have a CAN backbone shown by CAN high and CAN low wires. And in this particular topology, we have three ECUs available, which are ECU 1, 2 and 3. Now all of the ECUs have a hardware called as CAN transceiver. This is responsible for transmitting as well as receiving the CAN messages. On both ends of the CAN bus, we have 120 ohm resistors. These resistors are called as terminating resistors. The main purpose of terminating resistors is to avoid the signal reflection and to reduce the EMI in the CAN bus. The CAN wiring running from one terminating resistor to another is called as the bus backbone. Now based on protocol, this backbone has a maximum length of 40 meters for 1 Mbps communication. The distance of each ECU from the backbone is called as a stub length. The restriction on the stub length is 0.3 meters. Now let's have a look on what is a dominant bit and why do we really call it as dominant. A dominant bit is established when CAN high voltage is 3.5 volts and CAN low voltage is 1.5 volts and the differential voltage will be roughly 2 volts. CAN is implemented with a wired AND logic. This means that if any of the ECU establishes the dominant bit, that bit will remain on the bus and no other ECU will be able to change it to recessive. So what happens is if multiple ECUs are trying to communicate simultaneously, the one which is sending the dominant bit will be always successful, and that is why the bit is called as dominant. This principle is one of the major concepts of CSMA-CD which is used in CAN. We will go through it while we discuss on data link layer. This brings us to end of this lecture. In the next lecture we will cover CAN data link layer.